Hi guys, I hope that you're all doing well. Today's lesson is about grade 12 Euclidean geometry, the proportionality theorem. In this video, I'll introduce the theorem followed by some examples, and at the end of the video, I'll give you a few tips on how to master grade 12 Euclidean geometry. So what is the proportionality theorem? The theorem states that a line parallel to one side of a triangle divides the two other sides proportionally. Now, I know that you might be thinking that this statement doesn't make a lot of sense. Luckily, in math, we use statements and reasons instead of full sentences. So we have a triangle here. It's triangle ABC. Line DE is drawn parallel to BC. So DE is parallel to BC. It cuts sides A and B at D and A and C at E. Now, we prove this theorem using ratios. We can start with, let's say, AD. AD is from here to there. AD over, let's say, DB. DB is from here to there. Is equal to, when you choose the next sides, make sure that they match. We said AD, right? To see the side that matches, let's draw an arrow. It's AE from here to there. The sides always have to match. So let's say AE over, we said DB. DB is from here to there. Which side matches? It's side EC. So E and C. After you write the statement, you always have to give a reason. Your reason would be line parallel to one side of triangle. Your triangle is ABC. ABC. Now, there are different ways in which you can prove this theorem. We can start with different sides. Let's do DB. DB is from here to there over AD. AD is from here to there. Is equal to, the sides have to match. So we started with DB in the numerator. The side that matches is EC from here to there. Is equal to EC over, we said AD. AD is from here to there. Which side matches? AE from here to there over AE. And you also have to give a reason. Your reason would be line parallel to one side of triangle ABC. Now let's do a third way in which we can prove this theorem. Let's do AD over, AD is from here to there. We can choose the entire length. Let's do AD over AB, which is from here all the way to there, over AB is equal to, the sides have to match. We have AD, so the side that matches is AE. AE over, we said AB, the entire length. So let's also do AC, which is the entire length, AC. You have to give a reason, line parallel to one side of triangle ABC. Now, there are different ways in which you can do this. For now, let's just do 4 ways in which we can prove the theorem. Let's do AB. AB is the entire length from here all the way to there over DB. DB is from here to there is equal to, we had AB in the numerator. The sides have to match. So this would be AC, the entire length, AC over, we said DB, which side matches with DB, EC from here to there over EC. You also have to give a reason, line parallel to one side of triangle ABC. So it doesn't matter the order in which you start. What matters is that you make sure that the sides match. Now, in an exam, they might say that you should solve for x. You can also use the proportionality theorem to solve different lengths and ratios. Let's do the first example. Now, this is an exam question. Let's do, in triangle ABC, point D lies on AB and point E lies on AC. DE is parallel to BC. AD is equal to x plus 2, DB is equal to 4, AE is equal to x plus 3, EC is equal to 5. Solve for x. So I'll write down the steps for you guys on the side. You can copy these in your notebook so that it's easier for you when it's time to revise. So step 1, update diagram. We'll read our information again and apply what we read on our diagram. So in triangle ABC, point D lies on AB and point E lies on AC. Okay, then DE is parallel to BC. DE is parallel to BC. Then AD is equal to x plus 2. Where's AD? AD is from here to there. They said that it's x plus 2. Then DB is equal to 4. DB is from here to there. It's 4. AE is equal to x plus 3. Where's AE? From here to there. X plus 3. Then EC is equal to 5. EC is from here to there. It's 5. Solve for x. We've already completed the first step, which is updating our diagram. Step 2, we write our ratio and reason. So we start with AD over DB. DB is equal to, the sides have to match, right? We said AD. So the side that matches AD is AE. AE over, we said DB, the side that matches DB is EC. EC. And after you write this, you have to write your reason, which is line parallel to one side of triangle ABC. We've completed the second step. What's the third step? You substitute. We have AD. What's AD? AD is x plus 2. So write your x plus 2 over, what's DB? 4 is equal to AE. What's AE? X plus 3 over, what's EC? Excuse me, EC is 5. So you have x plus 2 over 4 is equal to x plus 3 over 5. What's the fourth step? Step number 4, cross multiply. So this would be x plus 2 multiplied by 5. You can write this as 5. X plus 2 is equal to 4 multiplied by x plus 3, which is 4 in your bracket, x plus 3. Now let's solve this. 5 times x is 5x. 5 times 2 is 10. Is equal to 4 multiplied by x is 4x. 4 multiplied by 3 is 12. Now let's group our like terms. Let's take 4 that side. You have 5x minus 4x is equal to 12 minus 10. What's 5 minus 4? It's 1. So we have x here is equal to 12 minus 10 is 2. So x is equal to 2. We solved for x. Before I continue, I'd like to let you know that this video was brought to you by Spotify. Spotify is a music streaming app that gives you access to over 100 million songs. You can stream your favorite artists for free, or you can get the premium version and have access to features like downloading music and streaming offline. For more information, go to open.spotify.com. Link in the description. Let's do the second example. In triangle ABC, points D and E lie on AB and AC respectively. DE is parallel to BC. AC is equal to 2x plus 4, AD is equal to x plus 1, AC is equal to 3x plus 6, and AE is equal to 2x. Now what's the first step? Step 1, update your diagram. We'll read this again and update our triangle. In triangle ABC, points D and E lie on AB and AC respectively. Okay, DE is parallel to BC. DE is parallel to BC. AC is equal to 2x plus 4. Where's AC? Excuse me, this should be AB. AB is equal to 2x plus 4. Where's AB? From here to there. It's 2x plus 4. AD is equal to x plus 1. Where's AD? From here to there. It's x plus 1. AC is equal to 3x plus 6. Where's AC? From here all the way to there. It's 3x plus 6. And AC is equal to 2x. Where's AE? Excuse me, AE is equal to 2x. Where's AE? From here to there, it's 2x. Now we've completed the first step. Let's move to the second one, ratio and reason. So I told you guys that there are different ways to prove the proportionality theorem. You can say AD over DB is equal to AE over EC. However, in this case, we don't have the lengths of DB and EC. So what I'd recommend is that you always use sides that are given. You always want to have less unknowns. So instead of AD over DB, let's say AD over, you also have AB, right? The entire length, it's given. So AD over AB is equal to, we said AD, which side matches AD? AE. AE over, we said AB, which is the entire length, the matching side would be AC. AC. What's your reason? Line parallel to one side of triangle ABC. Okay, we've completed the second step. What's the third one? We substitute. We have AD, what's AD? X plus 1 over, what's AB? 2x plus 4 is equal to, what's AE? 2x over, what's AC? 3x plus 6. What's the following step? I told you guys in the previous example that you should cross multiply, but in this case you have to simplify first. So just the tip, when dealing with the proportionality theorem, I'd recommend that you revise fractions with equations. I'll let you know which are the topics that you have to revise in the video's description, so please make sure that you read the description as it has more information about the topic. So to simplify this, we'd factorize our denominators because there isn't much that we can do in the numerators. So let's rewrite this as x plus 1 over, you have 2x plus 4. We should factorize this. Take out 2, open a bracket, you're left with x plus 2. Now, if you need to revise factorization, the link to the playlist will be in the description. Factorization was introduced in grade 9, and I've covered different ways in which you'll be expected to factorize. Is equal to, there isn't much that we can do in the numerator, so we just write 2x as it is over 3x plus 6. What's the highest common factor? 3. You're left with x plus 2. So what's the next step? The denominators cancel each other. We can cancel x plus 2 and x plus 2. We'll be left with x plus 1 over 2 is equal to 2x over 3. Now, this is where you cross multiply after simplifying. So always make sure that you simplify first. So we have x plus 1 multiplied by 3, which is 3x plus 1. Then 2 multiplied by 2x is 2 times 2x. 3 multiplied by x is 3x. 3 multiplied by 1 is 3 is equal to 2 multiplied by 2x is 4x. Now let's solve this. Let's take 3x to that side. You have 3 is equal to 4x minus 3x. 4 minus 3 is 1. So you have x, 1x. Therefore, x is equal to 3.